All right, good day, ladies and gentlemen. The panel of judges. I'm talking about scalar and vector quantity. And the one thing I want to explain is that it is in two categories. There's the mathematics aspect, there's the physics aspect. So I'm talking about the physics aspect, also the mathematics one, but in two different video then. This is the physics aspect. So for those that want to study scalar and vector, I want to have deep understanding, both the physics aspect and the mathematics aspect could help you. And this is more like the introduction part, so you have to calm down and listen to every bit of it so that you can understand better. Now you all know what we call a scalar quantity, right? But how can you make it understandable to a layman person that, okay man, this is what I'm talking about? Now guys, if you have to look at something, we all know that a particular quantity which has a number and also with an appropriate unit is what we call a scalar quantity. And without not stressing ourselves, there's one thing you need to note under it, is that under scalar quantity, it doesn't do with mainly any motion. In most cases, it's just like a verb functioning as a noun in that category. Then let's assume I said a class period is a class period lasts 50 minutes. This is the number and this is the unit. As you can see, a class period lasts 50 minutes tells us that the class period is actually 50 minutes, but nothing is happening there. So in this category, this is what? This is a vector. This is a scalar, sorry Jerry. This is a scalar. And we have a lot of examples of scalar quantity, which is your mass, your time, what else again? You have temperature, you have energy, and you have, most especially, you have distance. Most people, they don't know the difference between distance and displacement. So now we have to define this. Define distance and displacement. So people like, this is like, it's not balancing, not balancing the whole thing. Alright guys, so that is it. And there are many more also. You have your volume, and I guess I've dropped energy. So this is just normal thing. We need something that can boost this thing. That okay, all right, we understand that this one does not move. So what if it's not moving, going to and fro? Wetin go sup? What will be happening? Then we're like, bro, if it is moving like this, like that, it will need something more than just this a unit like this. So just ordinary number unit, or it will need more than that. It will also need what we call a direction. So that direction is what gives rise to the vector quantity. So a quantity which has only magnitude, that is mass, is what we call a scalar quantity. While the one which does not only have the mass, that is, it has the mass, which is magnitude, and also a direction, are you with me, is what we call the vector quantity. And you know, now in this kind of category, this one is higher than this one. God should lift us higher all the time. And like I said, we have different examples of vector. We have examples of vector also. And also, you can see that under scalar quantity, addition is possible, subtraction is possible, multiplication is also possible. That is multiplying a quantity times itself. Let's say I eat, I'll just try to put example. We have 1 kg of a particular stone, and I said I use triple of that particular stone. That means that 3 times 1 kg, that's automatically a dem of 3 kg. So yes, it's possible in scalar. Subtraction, addition in scalar is possible. But for vector also, you can add in vector, you can subtract in vector, you can multiply in vector, but division is undefined in vector. But don't worry, I'll figure that out myself. Don't worry, I'll discover that. I'll become the next Einstein. So moving on to that, guys. Adding in scalar is very simple, simply because you are not dealing with any direction. So it is easier to add in scalar. Add your 50 minutes for 50 minutes, you have 100 minutes. 10 kg plus 10 kg, 20 kg. 10 kg minus 10 kg, 0 kg. It's easy to multiply, add in scalar quantity. But when it comes to vector, you have to know the direction is also important. Are you getting what I'm saying? And like I said, some examples is your displacement. Our velocity, you all know that already. Our velocity, our acceleration, and many more. you have your velocity, your acceleration, and many more like that. So I guess let me see which one is okay. Or I guess the one you might not really be familiar with is the torque. You have torque, that's under that, and you have position. You have position. Yes, position is very important. Position, and what else do we have? You have your force. You already know you have force already. You have force. These are under scalar quantity, and this is the two. This is a particular thing I'm going to talk about today. That is the position, and position deals with a lot of things under your scalar and your vector quantity. If I'm to tell you now, let's talk about generally, a modern world. Don't look at your country. Look at a general modern world that is well developed. So that's what I'll be using to explain much more things today. So guys, there's a way to represent vector and there's a way to represent a normal scalar quantity. Now let's say a scalar quantity distance is equals to 20 kilometer. This is normal. You represent it normally, but for a vector, the displacement d will need a particular arrow, either an arrow or a line, any of the two you want to, but the most common one is the arrow. So an arrow has to be there, your 20 kilometer. Are you with me? So this is the two difference. For a vector, it needs a direction and a particular arrow at the edge, and this is a normal distance, a scalar quantity, which does not need that. Now I actually want to just use this. Don't worry, this is a latest Ferrari 5402, which is newly unleashed in Nigeria. So don't mind it. I drew it very well. So let me use this as an example. And mainly, I guess I've not talked about the vector quantity thing. See, many physical quantities, like I said, cannot be well explained with just a unit. Like I said, they do need the numbers and also what, a direction. Like I said, these quantities are called the vector quantities, and they used the arrow for representation. Now let us talk about the movement. This latest, what do I call it last time? Ferrari or Lamborghini? Any of the two. Ferralambo. The Ferralambo, the Ferralambo is moving in a particular category, right? And it is a physical quantity, as you can see, and also it can move. Firstly, it moves with a total distance and also with a direction. So when I want to talk about it, let's say this is total distance, and this arrow signifies the direction it is moving on to. So this is called the displacement, and this is total distance. And from here, this is the vector origin from here of the car, which is called the tail, and to here, which is the vector end of the car, which is called the head. But this is just like more of explaining the movement. So under the movement of the direction is where you find your distance also. Stop playing, guys. All right, let's move on. Then I want to explain something which is very important. Coming back to here, position. Let's assume my friend told me that my bro, I need you to go get me something from my tent. I lost my key in the bush, in the wood. He said he dropped it there. Okay, the key is at this particular point here. So you are moving from my tent to the bush, and you don't know the bush before. You can't just be moving anywhere from his tent. He said the bush is from my tent to this, but you can't start moving anywhere. He has to tell you the position of where you are moving to. When I tell you that, okay, the bush is 10 kilometer, okay, let's say 6 kilometer from my tent. He said 6 kilometer. Approved. Bro, since you tell me 6 kilometer, what should I use 6 kilometers to do? Should I use it to eat, or should I use it to bathe or wash? Alright, am I a magician? When you tell me 6 kilometers, the position is very important. Where? Is it north? Is it the east? Is it the south? Is it the west? That is the position, the work of position. Very important. That's so you have to tell me, okay, 6 kilometer north. Then I know that what my important thing is, what my direction is towards north. Are you getting what I'm saying? And let me tell you guys something. Is that the person moving from here now, from A to B, right? Let's say that is called vector what? Vector A to B of the person. Moving from A to B. And the person moving back also again, you have vector B to A. And I want you to think that if the person moves up from A to B at a particular verified value here, will this value here be equals to this value here? You have just 10 seconds to think of that. 1, 2, 3, 4, 5, 6. That's all. All right. Actually, if you are to say they will have the same value, now Will it have the same sign? 4 seconds remaining left. 1, 2, 3, 4. They might have the same value, but I'm sorry, with different sign, and I'll come back to that later. Now, like I said, now he's going to move from a particular point A just because the distance is 6 kilometers, and also again a direction that shows that what it is from A north to the bush to get the what to get the key. Are you with me? Now, if like I said, now the distance he used in getting to the bush would also be equal to the distance he used in coming back. That is the distance AB, which is equal to 6 kilometers, can be equal to the distance BA, also which is equal to what, 6 kilometers. So the distance of the velocity does not have any issue. Distance from moving here to here, 6 kilometers, from moving backward again from where you get the key to the tent, still 6 kilometers. Now, if you have to look at something, he moved, which is he has a specified direction he's going to, which is the displacement. But listen, guys, the distance, like I said, distance AB can be equal to what? BA. Are you with me? But the displacement, that's the displacement of AB. And you can write it like this, or you just say distance AB is equals to distance BA, any of the two. So the distance AB is equal to distance BA, but velocity, the displacement of AB cannot be equal to the displacement of BA. Yes, this is two different, like I said, it can't be equal to the displacement of what? Of BA. Now, if you look at, like I said, from A to B 6 kilometers, from B to A 6 kilometers, you have to come down and get every niche of all these things. This is what will help and assist you when you get to some calculation aspect to understand the position, this and that. Now, why do I say that the vector AB can't be equals to vector BA? Is simply because the guy moves opposite in his direction back. So therefore, the vector AB, is going to go and meet the lover of the key, which is his lover. I don't know why he's looking inside the bush there at the midst of forest looking for just ordinary key, because his brother told him to do that. Now, from A to B movement, like this, bro has to move. Then coming back again, movement, different direction. So therefore, you can easily say that the velocity AB can be equal to the negative direction of BA. This is acceptable and this is correct. Are you with me? So this is correct, and I hope we all understand something. Now, like I said, if I'm to tell you that, okay, my key lost in the wood, and this is the wood here, it is 6 kilometers from my tent. You can't just tell me it's only 6 kilometers. I need a direction. Is it north, west, south, east? That is one important thing I told you guys about. And also again, if I'm to move from A to B and B to A, the distance are the same thing, but the displacements are different. That is, if you understand this the other time, that means congratulations. And if you do not get it the other time, congratulations also, because you just understand the scope now. So I want to try to break down something to you guys, is that now let's assume that the guy actually didn't move normally like this. Let's say he moves the last aspect I want to break down is that, let's assume he moved. Okay, what about if he moved like this? And what about if he moves like this? To get to the key point, what about if he moves like this? To get to the key point. Now I want you to think your 10 seconds again, that will they have the same distance? I want you to think that. Now 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now listen, guys. Either it moves from here to here, or it moves from here to here, or it moves from there to there. Irrespective of any point it's going, so far it is the distance 6 kilometers, and it is moving actually northward, following the process. Any direction or any path is to take that will lead him to here. Firstly, as total distance of the same thing. And secondly, is that what? The displacement is the same. Are you with me? So these are all the same thing. These are all the same thing. And the last thing I'll be talking about under this now is the relationship between vectors. Relationship between vectors. And this relationship, I will later break it down very well under each slides of vector we're going to talk about. We're going to be talking about. And the first one is that let's say the question is to say that vector A. Okay, let's talk about this first. Let's say you have a vector like this, vector A, and you have a vector moving like this, vector B. Now if you look at this now, guys, let me make this longer. Yeah. Now if you are to look at it, guys, we can easily know that vector A is parallel to vector B. Yeah, parallel lines. They are parallel, right? But if you look at it, vector A can't be equals to vector B. Yes. Why is that? If this distance should be 4 kilometers, automatically this might be more than 4 kilometers, let's say 6 kilometers. So therefore, the distance also, which is A, cannot be equals to B. That is one important thing. So therefore, this is how we can notify it. Let's say like this vector A, and like this. Look at the vector B, vector A. As you can see, they are parallel lines, right? So they are parallel. Yes, it is parallel to each other, but it is not equal. Are you get what I'm saying? And who can tell me why is it not equal? I've talked about it now, but I want you guys to tell me why is vector A not equal to vector B? They are parallel. Now parallel lines are always equal, as we all know. But why is it not equal? That's one thing I want to know, is that 2 seconds. 1, 2. Why? The magnitude is not equal. That is why it can't be equal. So that is one thing. Now the second one is what we call anti-parallel. Anti-parallel. Now let's say you have particular velocity like this, a particular direction like this, moving sideways. Now let's look at this. Sorry about my drawing. I'm not much more of a drawer. I don't draw like that. Now you have vector A. Now if you have to look at this now, we have this moving in the straight line, same line. We say it is parallel to each other, right? Now this moving this way, this other moving this way. You have to say they are what? They are not parallel to each other. That is your A. This one is called anti-parallel. Anti-parallel, anyone to call it anti. So anti-parallel, parallel. They are called anti-parallel, moving in different direction. Now it is anti-parallel to what? To vector B. Are you with me? And if you have to look at now, guys, can A be equals to, and if they are anti-parallel, it gives a 180 degree. A 180 degree. Now since they are anti-parallel, what are you to think of? First and foremost, you look at the distance here, is the same thing. 4 and let's say 4. The distance of A can be equals to B. Yes, normally it doesn't have issue with. I think that the distance most time does not really have much issue. Just like an infant. But you know that adult is much more scam. Now velocity A, vector A cannot be equals to vector B. Why? What's the problem? Simply because A is moving in a particular direction where B is moving in opposite of that particular direction. So therefore your A has to be what? Has to be equal to the negative aspect of it. Now if I'm saying that A cannot be equals to B, yes. If it was to be that these two distances are 4 kilometers, A will be equals to B here. Why? They are parallel. But if you look at this can't be equals to this. Why? They are not parallel. They are anti-parallel. So I want you to know that. Then let's move on to something important. The third one. Now the third one, let's say you have a vector A, which is, now look here, anti-parallel to the negative vector A. Now if you have to look at this also again, I tell you that this is anti-parallel, right? Let's say you have two vectors of the same thing, A, which is anti-parallel to negative A. You know that it is opposite direction automatically. This moving like this, while this coming like this. Are you with me? So therefore, you have your vector A and you have your negative vector A. I'm coming. I want to shorten some distance, First and foremost again, your vector A here can't be equals to what? Your negative vector A. Should I tell you why? They have different direction. Yes, they have different direction. If I am to tell you that this is moving like this and with negative, they'll be equal. But you can see that this is moving here, this is also moving like this. So they are on different lane categorically, which means that your A here cannot be equal to what? Your negative movement of your direction. Why is that? They are not on the same lane. Are you get what I'm saying? So although the magnitude of a vector A, that's the magnitude of vector A, can be equals to magnitude of like more like absolute value of vector A, which can be equals to negative A. But these vectors, they are not equal. Now if you look at now, let's say you have distance of 4 kilometers here, distance of 4 kilometers here with the vector, you will see that what the A, and listen, like I said, A cannot be equals to negative A. Listen, that is the first thing I want you to understand. And like I said, their magnitude can be equal to negative A. They are both equal like that, yes. But what we are talking about is more of the direction, which you need to understand. And that is the third one. The fourth one now. The fourth one, in the sense that vector A is equal to vector B. To vector B. That is, if you look at this, you have A and you have B. You have B. You have a vector A. You are sorry that it is not well balanced. Are you with me? Now it says vector A is equals to vector B. And if you are to look, automatically you know that vector A is equals to vector B. Yeah. Yes, because this is 4 kilometers, this is 4. Let's see this 4 kilometers, this is 4 kilometers. First and foremost, they are equal. Why is that? They are both parallel. Are you with me? So they are parallel to each other. That is, they are equal. So moving on to this. A negative direction. Okay. Sorry, please. This is point here. Like this. So they are parallel. They are parallel to each other. This is 4 kilometers, this is 4 kilometers. So don't mind my Android. Sorry. They are parallel. So since they are parallel to each other and they have the same distance, they can be equal. So A is equals to BY, they are parallel, and secondly, they have the same magnitude, which is the same distance. And that is the fourth one. Now the fifth one is that vector A, whenever I have something like this, um, something like this, you know what I'm talking about already. So something like this. This is vector A, and this is vector B. Now if this should have the same distance, are you with me? If they should have the same distance, they call this orthogonal vector. That is, A is orthogonal to vector B. So they are called orthogonal vector. And who can tell me, still yet here, vector A is not equals to vector B? Who can tell me why? Vector A still yet is not equals to vector B. Why is that? They are moving in different direction. So take note of that. They are moving in different direction. And In since they are moving in different direction, they are not parallel to each other. Are you with me? So they are moving in different direction and they are not parallel to each other. So in this process, if you look at their distance, it differs with what we call orthogonal, which is 90 degree. Are you with me? So the 90-degree differs, or the difference between them, which is 90 degree, is what makes them orthogonal vector. So A is orthogonal to vector B. Now in this process, if you have any question, you can drop it in my comment section. I will attend to that and break some little things for down. And me, like I said, this is more like an introduction then, just for you to understand some little one or two things. So in the next slide, I'll be explaining them step by step for you to understand. And my name is Crypto Quanta. See you next time in our next class.